Bueno, buenas tardes a todos. Ya para ir finalizando vamos a ir arrancando con nuestra última sesión especial mientras va entrando la gente del público. Bueno, ya lo hemos presentado antes, pero para los que no tuvieron la oportunidad de ver la plenaria de isquémica, esta charla va a estar a cargo del doctor Michael Gibson. Michael Gibson es un médico cardiólogo intervencionista, pero que su especialidad son los ensayos clínicos. Él dirige y maneja el BAME Institute en la Universidad de Harvard, en Boston, y tiene muchísima experiencia en lo que es la investigación clínica. Ha sido el líder de gran parte de los ensayos clínicos que vemos en la práctica cotidiana, así que hoy tenemos la suerte que nos va a hablar sobre hacia dónde va la investigación, hacia dónde van los ensayos clínicos y qué nos depara para el futuro de la investigación. Así que, doctor Gibson, cuando quiera comenzar, arrancamos.
Great. Well, let me start with an audience poll. When you're doing one of these big practice-changing randomized trials, what do you think it costs per day to keep that trial up and running around the world? How many people say $10,000 a day? How many people say $100,000 a day? How many people say $500,000 a day? How many people say over $1 million a day? That's what it costs to keep one of these trials going. That's the answer. When you look at modern cardiovascular trials, it costs, in some cases, over $4 billion in development cost. We just can't afford to pay that much money. We've got to do things much more cost efficiently in the future. Well, we want to do things cheaper, faster, but good. That's always the three goals. We want to lower cost. Well, what if we had a way to get the costs down to 1 to 2% of the usual cost? What if we had a way to get things done much, much more quickly? What if we had a way to expand enrollment many-fold over where it was? And finally, the pandemic taught us that we need to do that. And finally, we need to preserve quality. The really important thing is to get not just quantity, but quality as well. Well, 40% of the cost in what we do in trials is monitoring. We're sending all these people around on planes to go to all the sites to make sure what's in the electronic case report form is what was actually in the medical record. What if we could reduce that dramatically? What if we could reuse registries to randomize people like they do in Sweden? Every person who comes through the cath lab is part of their registry, and you randomize people on those backbones. What if we didn't reinvent the case report form every time, and we just use more generic case report forms we could all agree on? Are there some newer statistical methods we could use? And I think we're coming up with those. Things like win ratios, things like proportional odds ratios that we can use. Regulators are becoming more comfortable with surrogate endpoints. Think of LDL. You can get your drug approved based on LDL lowering, but then you have to, over the next few years, show it improves outcomes. But one of the biggest ways and best ways we could lower cost is by doing virtual trials. That is, removing the bricks and mortar, removing the cost of a lot of the people that are involved. And I'm going to talk a little bit about how we have done this. Now, when I was young and your age, I see a lot of young people here today. That's really good to see. When I was your age, I used to participate in single center studies. Our hospital was putting in some of the first stents back in those days. Then we moved on to multi-center studies. Then we moved on to mega trials, tens of thousands of patients. But now we're at what I would call giga trials, where we're enrolling many tens of thousands of patients. And the amount of data we collect has moved from kilobytes to megabytes to gigabytes to now petabytes of data in a trial that I'm going to describe to you. So I'm running what's called Heartline. It's a trial where we compared an Apple Watch to nothing to detect atrial fibrillation. Now, we approached about 350 million people, you heard that right, to get 3 million people to come to the website and try and get into the trial. And we randomized 34,000 people to an Apple Watch or no Apple Watch. So very different. No doctors, no nurses, all done over the internet. You used an app to consent and to get educated. And we are following these people now for 2 years. The primary goal is to compare the Apple Watch to no Apple Watch to see if we can detect atrial fibrillation. That's the primary goal. Our second goal is to see, okay, who cares? Does that reduce events? So those are our two primary goals. Now, it was a big challenge to enroll people, but it's also a very big challenge to keep them engaged, involved in the study. And digital health studies have a wide range of engagement. Sometimes people are engaged, sometimes they're not. One study, the original Apple Heart study, only 44% of the time were they really filling out forms and complying. But I'm happy to report in this study, and we were very dumbfounded to see this, these are people over 65. We thought they wouldn't know what to do with the phone, but they turned out to be filling out their ePros, the electronic patient-reported outcomes, almost 90% of the time. So it was amazing to see them filling out information on depression, anxiety, weight loss, exercise, everything, 90% of the time. So rather than waiting on nurses and doctors to collect the information, we can collect a lot of information from patients. We were talking yesterday about this issue, and the tools are so inexpensive now. REDCap, you can design your own little database in REDCap, is practically free. And you know, for institutions, you can now use this very easy to design tool to collect enormous amounts of information. So it's the technology is not the limiting factor, it's the culture. And a culture has to decide, we want to do research. We want to enroll all of our patients in trials. Now, another thing we did is keep the patient engaged. How did we do that? We did it with apps, and we gave people news every week or every other week. Not dark chocolate is good for you news, but actual, real, credible information. So they would get all this news coming, and they actually liked it a lot. Maybe they had nothing else to do during COVID, but they seemed to enjoy getting that news, and that kept them very engaged. Here's some of the roadblocks, though. You have to hire writers, so we had to hire a lot of writers to create that news. Be prepared when you're enrolling people virtually. You have to have humans on the other end to answer their questions. So you have to have a hotline to answer all their questions. Be prepared to pay a lot to find the patients. In the past, we were paying to follow them. Now you're going to pay a lot to find the patients. Well, let's talk about costs. How can we lower costs? Right now, this number is old. I would say $30,000 per patient is the low end of the scale. I'd say in oncology, we're well over $200,000 per patient. And development of a cardiovascular drug is billions of dollars. We just can't sustain that. But the trial I just described to you, and I hope to report the results in the spring, is being done at 1% of the usual cost. 1% of the usual cost. If we could get that cost down, think of how many other drugs, devices, strategies we could test and reduce the cost of healthcare by doing this. One of the biggest costs in a trial, believe it or not, is tracking people down that you lost. It costs about $50,000 to track down a missing patient. Sounds like a business we should be in, you know? So very expensive to find those missing patients. So it's going to be different. I mean, trials used to be done in hospitals. You used a paper consent form. You used paper case report forms. But in the future, it's going to be more virtual. They're going to be enrolled by an app. One person is going to do a video that says, here's what you can expect from the trial. A good communicator will do that kind of video. And the patients will be reporting many of their outcomes themselves. So, in the old world, the way money worked was the doctor and the nurse got paid, but in the new world, believe it or not, the patient is the one filling out the case report forms and things. They may get paid. We are paying people for their engagement in the Apple Heart Study. Now, one of the things we do in trials is we don't take your word for it that something happens to the patient. We adjudicate that event. We have an independent group of doctors look to see, well, did that person really have a stroke or a heart attack? Here's what we're doing in virtual trials. We're not adjudicating things. We're looking at the insurance payments. So if someone paid for a heart attack, if they paid for a stroke, that counts. That counts as an event. Will regulators buy it? They do. Regulators have said that will count as an event. So the regulators, the FDA has approved this kind of method. Do you get the same answer if you use insurance or if you use what doctors said? The answer is yes. We've published 2 studies. There may be disagreement about some individual events, but the results of the trial as a whole are the same with the insurance claim and with the way we traditionally do it now. So we pay doctors money to adjudicate those events, but in the future, we will be having the claims database do this. The other way we've cut costs is by having computers go through and summarize the patient's history. So the computer goes through and it says, this is a fill in the age, year-old, fill in the gender, patient with a past medical history of fill in all the blanks, etc. So you don't have to have a human doing that. AI and algorithms now put together a nice summary of what happened to the person. What about source document verification? When I run a trial, there will be 50 countries involved. There may be 20 languages involved. Can you imagine the cost of translating all those languages into English? It's an enormous cost. But using AI, we've now got that down to about 10% of the usual cost. It goes through and does all the automated translation at 10% of the cost in the past. Big cost savings. What about speed? As I said, every day costs $1 million plus. It may be even very higher than that at the end. Getting people into the study quicker. Right now, these days, we hope and count on about 0.3 to 0.5 patients per site per month. That's a standard. But the Apple Heartline study enrolled 50,000 patients per month. So magnitudes of order, much more rapid enrollment. The other thing is, where do patients come from? In the past, they came from highly select hospitals. You had to live near the big city hospital. But in the future, the patients will come from everywhere. If you can get online, you can get into the trial. And it kind of distributes the enrollment more equally throughout a country. So how do you find all these patients? Lots of new strategies. One is using social media, things like Facebook, Twitter, Instagram, LinkedIn, all those sources. I would go on TV and talk to 30 different TV stations around the country to raise awareness of the program. There are different groups, like the Association of Retired People. They let their members know about trials like this. We're not cutting doctors out. Doctors play an important role in enrolling and letting their patients know. What didn't help was insurance companies. They didn't really help at all in finding patients. But in the future, I think a big source of patients is going to be the electronic medical record, at least in our country and other countries that have those. I spend a lot of my time figuring out, where are we going to find all these people in electronic medical records? We now have hundreds of millions of patients. We have the medical records on that we can go to. So say you want to test a new drug in people with an elevated Lp(a). Well, what we can tell you is within an hour or two, here's 100,000 people, 100,000 citizens who have an elevated Lp(a), who are not being treated. We can then go to those patients and randomize them. We have 50 million people with apps who go to gyms. We have 6 million people with apps who are getting food delivered to their home for diet. So for obesity trials, the gym can become the new clinic. The food delivery service becomes a new way you can find patients. Even in gyms, we're going to them now saying, can you get a DEXA scan in your gym so we can detect lean body weight versus fat? So, new ways. In countries, Brazil, they have 65 million people in a data lake that we can approach now. So if a country gets organized and has access to electronic medical records, we will be doing much better. At AHA, we will be presenting a trial about moving heart attack care into the home. You will begin the care in the home with the medicine you inject under the skin, sub-Q, a 2B3 inhibitor. So what we're trying to do is move care from the hospital into the patient's home, not just in chronic conditions, but in heart attack even, so in the acute setting. What will happen in the future is you're going to see more and more wearable devices detecting heart attack. So I studied for 17 years a device you implant. It would buzz and ring when you're having a heart attack. We got door-to-balloon times down tremendously with that. Now there's all kinds of wearables that will detect heart attack in the home. There's devices where you spit into a cup and it tells you, are you troponin positive or not? So what you're going to see is more and more diagnostics moving into the home, going direct to the patient so that we can get them into all different types of studies. Now, it's going to sometimes be hard to find those patients. As I said, we had to approach millions and hundreds of millions of people to find 34,000, but it's doable. The other thing we learned a lot about is how do you approach people? We would test different colors of the background of the email, and crazy things happen, like who would have thought an orange background with white letters would be the most popular one? I never would have guessed that. The other thing you have got to do is, again, have the human side ready. You got to have people on hotlines ready to answer questions when people call. Consent. Consent is critical. In the past, it was done with paper. Each IRB approved their own language. But in the future, you'll see more and more of this done electronically. It will be done throughout the world, not just in one IRB. When you enroll someone in their home, you can have an exemption from informed consent. They basically say, yes, I'm having a heart attack. You give them a paragraph about what you're about to do, and they consent with a very brief consent. Getting people enrolled is important, but how do we get the results out to the population at large? A few years back, I was asked to write about social media and the democratization of medical information. About 20 years ago, I created an open source textbook like Wikipedia. It's called Wikidoc, but it's for doctors. It's been authored by about 9,000 doctors, edited many millions of times. We get 1 billion views a year. It's free. It's copy left, not copyright, meaning anyone can take it, use it as they please. I was proud to cite that I thanked all my followers on Twitter and everything for all their insights in the article. But we've seen a fundamental change in how we give and get information. Now, if you haven't read it, there's a great book out there right now called Nexus. It's by an author named Harari. And here's his thesis. You know, bees are social, ants are social. There's plenty of social animals. There's plenty of animals that use tools. But what is one of the things in his mind that differentiates humans from other social animals? And that is, we tell stories. And we tell stories to organize people to have them move in a certain direction. And as society evolved, those stories became more and more abstract. They became more scientific. And now we have institutionalized storytelling. So when we say the FDA says, or the New England Journal says, this is the modern version of kind of scientific storytelling. Well, one thing happened, you know, as hunters and gatherers, you had small units. You basically trusted about 12 people around you. Then those 12 people had 12 other people. So a military group is about 150 people because 12 times 12 is about 150. But as society grew, we then began to institutionalize trust. So we trusted banks. We trusted the government. But sadly, I think we all know it, that many people have lost faith in some of those institutions. There's a lot of disinformation. There's a lot of misinformation. I think COVID created a lot of mistrust, sadly. And I think we have now shifted over to what's called distributed trust. So think about it. People are renting their houses to strangers. People are doing cryptocurrency. People are trusting ChatGPT. So trust has changed. We've rewritten the rules about trust. And now we have democratized storytelling. Anyone can tell the story. Anyone can have a big impact. That's good. It breaks down barriers. That's good. But it can also be very, very destabilizing. And it has become very hard to know what truth is and what is not truth. So I agree with them. Storytelling is very important, but we are at the risk of AI becoming the next storyteller, and we have got to be the humans curating that. So yes, we want to be good storytellers, but we want to be truthful storytellers. We want to be transparent and honest. But here's our biggest challenge. This sounds odd, but the truth changes. People can't handle the fact that what we thought last month is different than what we thought this month as we learn more. Our big challenge is to educate the public about how science works. Things change over time as we gather more information. So we have to do a better job of educating the general world about how science really works. I've been working about a year now creating a new social media site called Cred, where you'll have to be, in order to get scored on it, you have to be a doc. You have to show valid proof that you're a doctor. You'll get your Cred ratings. So instead of a like, you'll assign people scores. They'll get ranked. When you post something, AI will say, is this valid or not? If it's not valid, it goes to 6 doctors or more to check to see if it's credible. So we have got to restore the trust of the public, and that is one, I think, the big challenges in the future. Doing work, educating the public about how research works, and restoring our trust. Another thing that happened during the pandemic was the rise of the preprint. You know, people have just waited for, 6 months to a year to get their work published. That's not going to work in a pandemic. I personally don't think it should work that way right now. I keep trying to push sponsors to not wait on the ACC. Don't wait on ESC. Let's just present the results now. They're just so caught up in waiting on those meetings. But in a pandemic, that does not work. Remember, at the very beginning of the pandemic, we thought COVID was transmitted by droplets. But it was the original people who were hospitalized. When they began to sample the ventilation, they figured out that it was actually airborne. And they weren't waiting on the New England Journal or something to publish it. So put on a preprint service changed everything. So you'll see an acceleration of that. I want to see patients presenting the trials in the future. I'm trying to set up a meeting where patients will present the results of the trial that they participated in. So my right-hand person who scheduled me to be here, her mother participated, I didn't know it, in a heart-line trial. She wore the Apple Watch, it detected AFib, and she got treated. So that would be the ideal kind of patient to present the results of trial. I don't care to present it at a big meeting. We should have the patients presenting the information. What can we do to improve quality? I think the bigger numbers we have, probably the more accurate the answers we're going to get. I think we'll be able to monitor safety in real time, as I'll show. We'll be able to have less missing data using our digital tools, and we'll have more representative data. Many of you know how it works right now. You send in the case report form, and then someone has to translate it, and someone has to then issue queries to you, and then it goes to a human committee to look at. It takes months. And by the time you get the answer, it's really far behind where the trial is. With the new system, by going to insurance codes and things like that, we'll know in real time, right now, with someone discharged with a stroke or heart attack, we'll know much more quickly what's going on. In the old days, we've always sweated out, oh my gosh, did we have enough patients? Are we going to have enough statistical power? The problem will actually be quite different in the future. We'll have so many patients that will definitively answer the question. That's not going to be the issue. We may have statistical significance, but the problem in the future is going to be, did we have clinical significance to what we found? Now, we're also going to be able to test a lot of second hypotheses. A lot of missing data in trials. With the new method where you track everyone down through claims databases, will minimize missingness. I think the new strategy of not having highly controlled trials of everyone doing pill counts will give us a better sense of the way drugs work in the real world, not in a fantasy world. I think because of all that, we'll have much more generalizable results. Will this really work when it gets out into practice? That's where we're kind of right now. What are some of the other things that will be going on in the future? I think artificial intelligence will do a lot to help us. We'll be collecting data as we go. We kind of do this now, but you know, if your trial is going on and you see you're not going to have the event rate that you thought, what we do now is we enroll people at higher risk. But imagine being able to do that in real time, but also figuring out who are the people who are really at high risk. So I think you'll have better ongoing kind of modulation of trials to get them done quicker and better. One of the most important things is this. In the past, we have guidelines, and guidelines have been very good. Guidelines tell you about the typical patient. Guidelines tell you about the population, but we don't take care of populations. We take care of patients. And the patient, to be honest, doesn't really care about everyone else. They care about themselves. So we want to make a recommendation for this individual patient who's right in front of you. And that's really what I think the power of AI will allow us to do in the future. Now, this is something I'll be presenting at an upcoming meeting. Imagine this. What I wanted to develop was AI that acted like a doctor. So, you know, individual patient prediction, right? What do we do as doctors? We see people every 3 to 6 months to see how they're doing. Now, your risk at the beginning may be quite different than 6 months later. If you've been on a drug, an anticoagulant for 6 months, and you don't bleed, you've passed your bleeding stress test. You're a different patient. So we need to make iterative assessments of risk. We also need to ask our patient, all right, would you rather have an ischemic stroke or a bleeding stroke or a transfusion or a GI bleed? You know, how do you rank? How do you rank all these bad things that happen? Now, how you rank it may be different than how you rank it, and so we want to do it on an individual patient basis. And when you do all that, iterative assessment, individual patient preferences, you can come up with this, where you say to a patient, based upon the fact that you are, in this case, this is an 80-year-old woman with a creatinine clearance of 42 mLs per minute, the best strategy for you is this one on the far left, a dose of 15 milligrams, okay? So older lady, 15 milligrams is the optimal choice. Here's a 72-year-old man with good kidney function. The dose that gives you the lowest event rate is the high dose. So you get different answers depending upon what the characteristics of the patient are. So that's how we're going to be, I think, helping patients with shared decision making. Access. In the past, you had no access to the records of what was happening to you in a trial. But in the Heartline study, your family can be notified of what's going on. They have insight into that arrhythmia you just had. So you'll see more sharing of data with family members. So I'm the only thing that stands between you and dinner. So I'm going to wrap up now. So here's the way the world will change. In the old world, it was bricks and mortar, hospital-based paper. In the new world, it's going to be much more virtual and apps. In the old world, the doctor and the nurse assessed your outcomes, but in the new world, insurance claims or electronic medical records will assess those outcomes. The consent in the past was paper-based and local. The consent in the future will be more electronic, with one very good communicator talking to you about the risks and benefits. The sample sizes were in thousands in the past, but now we're going to be looking at tens to thousands to hundreds of thousands of patients. Vaccine trials in particular now are going to be many hundreds of thousands of patients. I'm going to be doing a trial that'll have 500,000 people looking to see if the use of AI to guide decision-making in EKG interpretation improves outcomes. So we're talking about 500,000 people in these trials. Representativeness in the past was highly select. It'll be much more broad. The person recruiting it will be TV, radio, Facebook, social media, not necessarily a nurse or doctor. We will be screening lots of people, but we will be driving the costs down, I think, to something that is much more affordable. Will all this happen overnight? No. The trial I'm running, Heartline, is all virtual. Will all trials be all virtual? No. The best fit for this is going to be phase 3, phase 4 kind of trials, not very early trials where it requires a lot of blood testing. Although I will say we can get blood testing into the home, we can get echoes into the home, we can do blood pressure in the home, but it's really going to be more for implementation science, for phase 4 trials, this kind of hybrid model. So I think we can get there. We can lower our costs dramatically. That's really important for us as a society. It allows us to have more shots on goal. Hopefully it'll also lower the cost of developing drugs because you as consumers and patients are paying for the development of all these costly drugs. But I think the future is very bright. I don't think it's going to replace doctors. It's not going to replace nurses. It's going to allow us to minimize the cost, really improve the efficiencies. We will still be the curator of knowledge. We've got to make sure ChatGPT and AI isn't hallucinating. And I hope all this will give us more time with our patients. We shouldn't be working for digital health. Digital health should be working for us. Let's not become glorified data entry people. That's got to change too. But in the end, I think if we can use tools like passive listening to record what the patient was saying and type it all up, if instead of entering everything at a keyboard, if we can use AI and all those tools to actually look at the patient, talk with them, and form a bond, I do think we can use these tools in ways that will actually improve things. We're not there yet, but I do think the future is bright. Thanks for inviting me. Wonderful conference. Thanks for inviting me.
Bueno, pues una
¿Vos una pregunta?
Sí. ¿Tenés?
Bueno, lindísima la presentación y muy lindo ver todo este plano, este proceso de análisis a futuro. Mi pregunta desde el rol de la gestión de una organización, permanentemente recibimos información con respecto a la seguridad, con respecto a la eficiencia, pero poco hay sobre costo-efectividad. ¿Cómo ve usted el tema de costo-efectividad? ¿Qué es lo que realmente impacta sobre el sistema de salud o sobre las organizaciones en función de esta nueva línea o esta nueva mirada que usted propone?
Well, I used to. Hello, can you hear me?
Yeah,
Yeah,
I can hear.
good. I had the great misfortune of running a cath lab with 92 interventional cardiologists. And I was vice chairman of medicine at a large hospital. And doctors would come crying, I want every stent in every size. And one of them put 17 stents in one patient. And what we began to do, which is the right thing to do, is what's the cost per operator in treating a patient? And we began to rank them. And, it can be very eye-opening. There can be some operators that are 1/5 the cost of other operators. I do work with a company where we have software in 72% of U.S. hospitals that looks at every piece of equipment that was used. We can tell you the unique identifier of that valve. That valve has this one, that one person. We can tell you the surgeon. We can tell you the room. We can tell you every piece of equipment that was used. We can tell you the total cost. We can now tell the FDA, and the FDA is very interested in this, how many repeat valves were done. And so we're using, the software that manages inventory to figure out how many aortic valves failed. So we can track if this patient came back in and had a new valve. So I do think by collecting all that data, and see, the beauty is there's not a human being typing that in. They're scanning that in, and it's all going into a database. So I do think you can look at it in ways with, if you have your own statistician and your own cost person to look at it cost per operator, strategies like what you've been doing with your radial area, everything you're doing to drive costs down to make quantitative measures.
Lucrecia.
I was the cheapest operator, by the way.
Muy bien. Dar el ejemplo.
Un gusto escuchar su conferencia y las perspectivas acerca del futuro de la investigación clínica. Siempre me interesa mucho entender cómo piensan ustedes, con lo cual me gustaría hacerte una pregunta un poco rebuscada. Con el conocimiento actual y con las nuevas reglas, el nuevo orden que se viene en el futuro de la investigación clínica, pensando en tus landmark trials pasados, que son muchos, ¿qué harías diferente? ¿Qué rediseñarías? ¿Y qué harías en un futuro en los nuevos ensayos clínicos, teniendo en cuenta The New Order?
Great question. My son is an oncologist, and I tried to make him into a cardiologist. He worked with me at TIMI, he worked in the TIMI core lab. He counted TIMI frames. He didn't want to be a cardiologist. He's an oncologist. And he's always making fun of how we do trials. They do something very, very, very creative. They'll have one control group and 16 different strategies they're testing. Someone will have breast cancer, and they'll do the genetics. They'll do the proteomics. And they'll say, given your genetics, you should be randomized to this chemotherapy or this intervention or to the placebo group. So they're sharing the placebo group so that you're not redoing the placebo group all the time. You only have 1/16 of the people in the placebo group. And you have all these competing trials going on all the time. And if a trial's not working, you kill it. And then you say, well, this didn't work for you, but trial number 4 may work for you. So it's a much more creative way of doing this. It's not a technology issue. It's not a science issue. It's a culture issue. My sons and I argue, they're both PhDs from MIT, and I always say to them, science is easy. their heads explode. They get really mad at me. People are hard. And, you know, changing inertia, changing culture is much harder than science. So if we all got together in industry and we said, okay, there's obesity. We've got a lot of obese people. We're going to have control patients. We're going to have active treated patients. The entrance criteria, inclusion criteria is going to be very similar. We're all going to agree on the rules of engagement. We're all going to agree on the common case report forms. And we're only going to have 1/16 of the people getting nothing. That would be huge because right now, by 1-to-1 randomization, half the people want to stop the trial because they're not losing weight. So there are ways we could make the whole process more efficient, less costly, but we've got to change our culture to be more like oncology if we want to do that.
¿Otra pregunta?
And don't ever tell my son I gave him credit for this.
Mientras hablaba, doctor, yo pensaba, en los últimos años hemos tenido varios estudios de características un poco más pragmáticas. Estudio DAPA en infarto de miocardio, estudio Dancabas en la población danesa, donde enviaron mails para invitar a la gente a que se screenee y a los otros no les enviaron. Me da la sensación que cuando la población cardiológica lee los resultados, tiende a subestimar el impacto por la característica menos estructurada que tiene el estudio. Entonces le encontramos explicación a los resultados. Mirá cómo lo hicieron. Los pacientes no fueron vistos en el seguimiento en DAPA-MAI. Solamente buscaron datos en la base de datos. O sea que la adjudicación pudo haber sido errónea. En Dancabas algunos pacientes participaron y otros decidieron no participar. Entonces, ¿es necesario cambiar la estructura o es necesario cambiar la estructura mental nuestra de qué es válido y qué no es válido?
Well, you're raising the very important question of doing something that's very well done, high quality, highly structured, and is the perfect science experiment, right? Versus what really happens when you have a drug out in the real world. I think in the past we've done some really great structured science experiments. We've really kind of asymptoted, though, in some fields where we have some pretty good care. It's going to be harder and harder to show major improvements. But if we're talking about cost, we want to have interventions that in the real world make a difference, right? Now we can do better kind of high quality assessment of what's going on, but we can't make people take their pills. We aren't going to have pill counts in the real world, things like that. So I think the real world assessment gives us a more close approximation of what's going to happen. DAPA-MI was very, very important because the FDA said you can use insurance claims to see if someone had an event. So I think we're moving more in that direction.
Hay una contrapartida de ese punto que es que a veces el ensayo randomizado, hipercontrolado, con criterios de inclusión muy estrictos, después no le creemos porque decimos que están hiperseleccionados los pacientes. Entonces, ¿cómo llevamos a la evidencia de mundo real mucho más aplicable a la población? De la forma que decía Juan Pablo, creyéndole a los resultados y que creamos que lo que sucedió realmente es así, que es la verdad, ¿no? Ese es el desafío.
True, but I'll say this. I don't think trials don't fail because people didn't take their pills. Trials fail because the way you set it up at the beginning, you thought there was going to be a 10% event rate, and oh my gosh, the event rate was 6%. And I can't tell you how many trials go wrong because no one ever looked. But in the trials that I run, we're looking every month or so at the blinded event rate. If if we expect it's going to be 10% and 8%, well, we better be coming at a 9% event rate, a blended average, to have the events we want. And if we're not, in the past 2 trials I've run, we've changed. We said we need to enroll for higher risk patients. So it's not because people aren't taking their pills, it's because we're not doing our jobs, or other trialists aren't doing their jobs to make sure they're doing the study they thought they were going to do.
Marcelo.
Yo me quería preguntar.
Oh boy, the chief of cardiology is going to ask me a question now. This is hard.
¿Puedes activar?
Guárdalo.
I told them to turn the chief of cardiology's microphone on to avoid the tough questions.
¿Qué?
They gotta give him one of the microphones. Do you have another one?
O
No anda ninguno.
decila y te la
Ninguno.
parafraseamos.
Ah, ¿qué me material?
¿Alguien quiere hacer otra mientras Marcelo recupera su micrófono?
The question is related with. Hola. Sí, ahí sí.
Ahí está.
Mi pregunta tiene que ver. Gracias.
Ahí está.
A ver.
Gracias.
Hola.
No, yo no.
¿Se escucha?
No, creo que cuando sos vos el problema, Marcelo.
se escucha, se
Estamos
escucha.
inhibiendo.
No, creo que ahí anda.
¿Se escuchaba?
Creo que
Sí,
ahí anda,
se escucha.
Marcelo.
¿Se escucha?
Para subir la audiencia, Alberto va a hacer en este momento un descamisamiento en vivo.
Creo que anda, Marcelo. ¿eh?
Ok. No, mientras escuchaba su excelente charla y muy provocativa, yo pensaba en mi propia evolución en mis ideas de investigación desde que empecé siendo muy jovencito a la actualidad, donde evidentemente pareciera que se había mejorado muchísimo en muchísimos aspectos, en los estudios randomizados, el CRF, los comités de ética, los monitoreos, todo eso parecía haber perfeccionado la investigación, y ahora nos encontramos que es un costo impagable de una población que es difícil de llevar, comparar con los otros, que no sabemos si los estudios que hacemos nos aportan a la investigación, aportan al investigador en cuestión. Me parece que la propuesta de salir de todo este embrollo de situaciones frente a otro tipo de investigación, me parece que ese es el futuro o el presente, porque ya está haciendo, como bien decía Juan Pablo, en la época de la pandemia, los estudios que se han hecho por necesidad de no tener toda esta estructura armada de investigación, nos obligó a pensar otra manera, y creo que lo que usted propone en cosas más sencillas a través de métodos electrónicos y demás, me parece que claramente no veo otra posibilidad que sea el presente y el futuro. La pregunta es, ¿no se está creando también un sesgo cuando el paciente tiene que acceder a métodos electrónicos y demás? Probablemente actual, seguramente en el futuro esto ya no va a pasar más, pero ¿no hay un sesgo también en el que a su vez decide participar o es incluido a través de esta nueva metodología?
Wow, there's about 10 questions there. Let me try and remember some of them. You know, when penicillin worked, you didn't need 40,000 patients in a Gusto 1 trial to show it worked, right? So we've gotten to a point in cardiology where we're kind of asymptoting. We've got some really great therapies. We talk about 0.5% improvements, 1% improvements. You know, are we going to want to pay for that? That's a big question. One of the other problems is we keep adding on. We add on, and here you got one antiplatelet, a second antiplatelet, let's add an anticoagulant. We never seem to take away and replace. We have got to do trials better in the future where we're brave enough to replace old strategies. Aspirin. We love aspirin, right? But it's due for a change. I mean, it causes GI bleeding, and we have safer alternatives like the thienopyridines. But it took us 30 years. Aspirin was king, and then clopidogrel came along, and then it was, well, clopidogrel was better, but we should combine the two. Let's combine the two. And we combined the two, and we said, yes, dual antiplatelet therapy is better than aspirin. You know what we never tested was whether aspirin added benefit to clopidogrel. And the answer is probably no. So we don't do a good job of replacing things. We've got to do a better job of taking more shots on goal at a cheaper cost with strategies that will replace what we're doing right now, then adding on and adding on. We've also got to work with our regulators to say, look, this flying people all over the world to compare what's on a piece of paper to what's in the computer is ridiculous. We had a trial where 19 people had the same EKG, and a monitor going in looking at one EKG is never going to find that. So we have to have better fraud detection systems saying this EKG appeared 19 times, that's fraud, rather than a person flying all over the world taking 40% of the cost in a trial to look at that. So we need better fraud detection. We need simpler regulatory strategies. I think the regulators took a big step forward in saying insurance claims could substitute for event adjudication. But you're right. We're never going to, as a society, advance population health if we don't do this. There's a lot of p-values. We've only focused on the p-value, which is the statistical p-value. The most important p-value is the patient. You know, if they can't get access, it doesn't matter. The other important p-value is price and payments. The other important p-value is physician. Is the physician going to be able to prescribe it, or are they going to be so overburdened they won't prescribe it? And the other p is population health. And the pandemic, the other p, really highlighted that we've got to answer important questions quickly and get it right. It was a real eye-opener. People were saying this drug works, that drug works. People who got this drug did better than those, but it was all observational data. It was not randomized data. The randomized data showed no benefit to what the observational data showed. So we've got to hold things up to a randomized standard. There's a lot of people trying to use observational data to replace trials. I just don't think that's going to work. We just got to make trials cheaper.
Mariano, Pablo. Doctor, otra de las consultas que nos generábamos hoy era, en los últimos años la industria ha focalizado la investigación preferentemente en enfermedades más de nicho, en drogas que terminan teniendo altos costos que son inaccesibles incluso para países de alto poder económico. ¿Cómo hacemos para cambiar eso? ¿O cuál es su visión de eso? Si eso está pasando o no está pasando.
It is, and it's driven by economics and the cost of doing a cardiovascular trial. You're in one of them, the Milvexian study, $4.4 billion. Who can spend $4.4 billion to study a drug? It's just not sustainable. So the people in companies have said, we don't want to go into cardiovascular disease because the studies are too big and too expensive. We want to go study a rare disease and do a trial of a couple hundred people for a fraction of the cost and then go charge those people gazillions of dollars for the drug. We've got to change that. Again, that's what we're all saying. We've got to be able to do cardiovascular trials less expensively to make it relevant again from an economic point of view. It is the world's leading killer, but we're not spending the money we should be because it's too expensive. We've got to change.
Mariano.
Una pregunta. ¿Esta nueva forma más pragmática de hacer estudios, usted cree que es aplicable a todas las áreas de la medicina cardiovascular? ¿Hay algunas áreas en donde es más aplicable y otras menos aplicable?
It is. I think it is more applicable to later phases of drug development or device development. It's more applicable to things where you don't have to go in and do an echo or blood test or things like that. It is pretty applicable on the drug side. I think the device side is a little tougher in some cases. because you want to look and get an echo to look at mechanical failure of valves. But on the other hand, I do think we're going to make some strides. There's patches that you wear now that can do ultrasound through the patch to monitor things. So the technology will catch up, but I think in most areas we can do it.
No sé si hay otra pregunta, si no, ayer tuvimos el placer de poder conversar con usted y yo veo que hay mucha gente joven en la audiencia a esta hora y hablábamos de cómo seguir estimulando la investigación como fuente de un pensamiento crítico, más allá de lo que uno pueda realmente aportar a la ciencia como resultado. ¿Cuál sería su consejo, con su experiencia para todos estos jóvenes que están aquí hoy con nosotros?
Well, I feel so blessed to have been able to participate in a lot of the early trials back in the 90s. When we began doing large trials, it was the most exciting part of my life and was a golden era. But I have to say, there are trials, and there are the trials that change practice. It's very life-changing to participate in those. I think we've got to change our model of the rewards. There's very big science done like CERN. CERN has tens of thousands of people working on it, right? Why are all those people working on it? There can only be one first author, right? So they have a distributed system of credit for what they do. What they discover changes our knowledge, and everybody gets credit. I think part of the problem is authorship and people getting all the credit when the credit should be more widely distributed. I think medical schools should be giving people more credit for their participation in trials, not being some first author on the trials. So I think we got to shift how we give people credit to make everyone feel like they changed care. Now there's trials, and what I've learned over 4 decades is that drugs come and go, but you know what never changes? It's the pathophysiology. So I was a kid in a dark room, the age of all these people in this front row or younger, when Eugene Braunwald said to me, I heard great things about you. I want you to be the TIMI angiographic core lab. I had never seen a moving angiogram. I had looked at movie frames one at a time under a microscope to measure atherosclerosis regression, and I actually turned it down. And Don Bain, my mentor, said, no, Mike wants to do it. So I got scared to death that I was going to get fired if I didn't know the difference between slow and normal flow. So I began to count all the movie frames down the artery. And, you know, in those days, we didn't have PowerPoint. You had some guy in the basement making up your slides. And so he never got to see the slide before I presented it. But I said, at a big meeting, I said, well, here I've been counting these frames, and here's what normal flow looks like, and here's what slow flow looks like. And I called it frames to opacification. And Chris Cannon slipped over a little piece of paper, and it said, Braunwald said, call it the TIMI frame count. The point is, you don't have to spend money. You know, you just have to be a good observer, have some ideas, study something intensively. It had a bearing on pathophysiology, the microvascular. It turns out, I kept telling him, no, it's not the stenosis, it's the microvasculature. He kept saying, no, you got to be crazy. But it turned out the microvasculature did play a big role, and I looked at the angiograms and discovered the blush, the myocardial blush. These were free. You now have so many tools in the cath lab that you can measure IMR, FFR, every R in the world, and you can do beautiful studies with limited number of people that really change our understanding of biology, our understanding of pathophysiology. That in turn leads to future ways that we change practice. So everyone can make a big contribution. It doesn't have to be, you know, the big New England Journal paper on some randomized trial. Those come and go. But the idea of the microvasculature, of how that's mediating outcomes, that never changes. So when people talk to me, I say, you can make more important contributions that are forever by studying pathophysiology. And that's, you know, as a young person doing those boutique studies that take tens of patients, not tens of thousands, you can make important contributions.
Cerramos.
Bueno, estamos justo en horario, así que vamos a ir cerrando la sesión. Muchísimas gracias, doctor Gibson, nuevamente por estar con nosotros. Ha sido un honor enorme tenerlo acá con nosotros en nuestro precongreso, que ha venido muchísima gente a verlo y a ver a todo nuestro trabajo. Así que muchísimas gracias por haber venido. Damos por cerrado la sesión y en unas breves palabras ahora daremos por cerrado el congreso. Muchas gracias a todos.
Gracias.